I'm an assistant professor in electrical and computer engineering and affiliated assistant professor in engineering public policy. I teach electric power systems, an undergraduate course teaching the fundamentals, and in spring semester I teach the graduate level course optimization in energy networks. So I'm mostly focusing on the optimal operation of the electric power system, looking at how do we coordinate best different elements in the system, such as generation, load, storage devices, and so on. So in the past we had mostly large power plants which were producing the electric energy, and then it was transmitted to the loads, and the loads were just fixed. We supplied them as needed. But now moving towards distributed generation, having hopefully having more storage in the system, and flexible loads, meaning that you might be able to tell the utility, okay, you can adjust my thermostat such that you're becoming a flexible load which they can adjust. Most of my work focuses on developing methods and algorithms to optimally use elements that we have in the system. So what I'm basically trying to do is, let's say you have a storage device, but the storage device itself doesn't help you much yet. You need to know when to charge, when to discharge storage device, and so on. So I'm providing the method to get the most out of that storage device. The goal of my work is basically to minimize the cost by optimally using the existing components that we have in the system, as well as integrating new technologies, make optimal use of these technologies, especially in the viewpoint when we think about, well, we want to move towards a renewable energy future, and often the counter-argument towards that is, well, it's so much more expensive and so on. So especially in this situation, it's highly critical that you're making optimal use of what you have in the system.